like Dangote business in their pipelines, I think oil and gas from the very remote area in the ocean, to the ocean or to these forest, very remote area that you have no satellite, no internet connection and no Wi-Fi connection. So if there is a leakage in the pipes due to many reasons, vibration due to corrosion, because they have lots of pipes.
Okay.
Then you would have the possibility of satellite providing the internet connection. In our case, it's about 500 kilometers up in space, the satellite, launched by the South Australian government. $6.5 million satellite, which is the size of a shoebox. And so these are low orbit satellites that will monitor and track the data from the pipes real time, meaning that if there's pressure change, we know that there is a leakage. Just like your tire pressure. It changed from 36 to 26. Then we know there's a problem with the tire already, there's a puncture. And in this case, it's the same. We measure just one example of measure pressure. We can measure the strain of the pipes too, because when you force high pressure gas and petroleum through the pipes, you normally would have a lot of stress on the pipes. So this stress can be measured in very minute quantity and sent to the satellite. Because I repeat, this application is real-time made possible by satellite because these pipes are going through places that have no connectivity. So that's one critical application that relates to climate change. Because this carbon leakage and things like that, in fact, just about a month ago in Malaysia, this pipe exploded near to residential area that was piping gas into the petrol stations. And it exploded. You can see it from miles away. So it could have hurt people. So this is an area where business relating to petroleum, climate actions is where you need this eye in the sky. In fact, assets, like a very expensive shipment from Australia to Nigeria, of cattle or whatever animals, right, that we ship. And through the ocean, again, there is no connectivity. You do not know whether the fan has stopped. If the fan has stopped, then the animals produce a lot of waste, and the ammonia will harm their health. And by the time they arrive in Nigeria, there will be half the animal that we send to you. So through satellite, we know whether the fan has stopped, and then monitor the jet.
Okay, Mr. Chu, and let me go now to Mr. KOSTECKI, and let's ask about how we can use the Earth low orbit to enhance IoT connectivity in remote areas. Since we are talking about businesses and the satellite, and we believe that the satellite should get to everybody at every corner wherever they find themselves. So Mr. KOSTECKI will be telling us how businesses who reside at the remote areas will be able to use the Internet of Things, especially using the satellite-based development of a digital space to ensure that their businesses run and run well. Mr. KOSTECKI, I was asking you about why you think the low Earth orbit satellite should be used in areas, remote areas that we have businesses. Do you think that can be achievable? All right, Mr. KOSTECKI, did you get my question?
Yes, I did. Yeah, sorry. Just a little bit of trouble with the audio, but I think I got the question.
Okay.
So the low orbit satellites are the ones that really have the low cost. The other satellites really are very expensive if it's a direct connection all the time. So the low orbit ones reduce the cost, and the cost is obviously very important for the bottom line, the profit of the business running there as well. It also, in fact, such a low cost that we have our local low Earth orbit supplier here is able to provide a service just with each packet of data can be just like 1 cent. 1 cent US, or even less than that for larger amounts. So when they're deployed in many locations, then it still is achievable even for farmers. Even it can be used for enterprises that are small businesses, or even for example, for universities to be able to actually do that. But what's really been the problem though with the satellites is being able to deploy them without the cost of time and effort, and being able to actually put them in. They've been very complicated to put in actually. So places like universities have found it too difficult, even for university students and of course younger ones. So businesses even don't have that time to invest to put that in. So technologies such as the ones that STEMSEL has put together now, called RunLink, actually have low code and artificial intelligence, AI, to help them to very rapidly be able to do that and save potentially millions of dollars actually trying to put that in. So it's affordable in fact for farmers and others too. That's very important, the affordability of it. The facts that the low orbit satellites only come maybe once every 15 minutes, once every 2 hours, also obviously affects it, but you have to cater for that. In the meantime, you can still store the data and you can send it when they're available.
Okay, Mr. Chu, let's talk about the affordability of this satellite development that we are talking about. We know that a lot of people who are still used to the traditional way of using the internet, the Wi-Fi, the cellular and all that, they are still struggling with it. So we want to go satellite now. How do you think they can move and balance up, moving from the traditional way of using the internet to the satellite way of using this internet? Will it be easy? Will it be affordable, especially for small and medium enterprises?
The cost issue is the main problem. So you could have Elon Musk Starlink. It's available already. But not many people can afford that, right?
Yeah.
Small businesses can't afford that. Students can't afford that because it is a subscription fee, it's a setup fee. And therefore, to make it accessible to students and to small businesses to increase their profit in the business, because there's no communication, like you say, and the internet is not reliable. And yet they can't afford what is already in the market, called Starlink. But even in Asia, it's too expensive for the ordinary people, the small businesses. So what we are trying to do to make that accessible is to have a Starlink that is very low cost, right? So the satellites that we make use of at the moment, like Miro said just now, there is latency.
Okay.
It's very small packets of data. So it's not, it's for critical applications, like a pipe explosion, like tracking the very expensive assets. You could have a $20 million assets in the jungle, and unless you have satellites tracking it, you could lose your assets. So those are critical applications for businesses, and we have made it very affordable in the sense of this type of applications for climate change measurement of temperature, humidity, melting ice, and things like that. Can be used by these type of businesses that are involved in climate actions type of businesses. So I hope that the audience listening in understand that to go to the next level of Starlink that is very, very affordable, so low cost that anybody can use it, you need a lot more satellites. Like Starlink has 6,000 about. Yeah, SpaceX.
Yeah.
And through collaboration between Africa and Asia, we could launch 10,000 satellites. It's only shoeboxes size. It's not hundreds of millions of dollars. Each of these could be just about $500,000 US to make them and to launch them, another lot of money. But it's not talking about the figures of hundreds of millions of dollars of these specialized satellites. So to increase profits for businesses, you need really another solution to be able to get all the satellites up there. And that's why I mentioned about Mr. Dangote. Has a university in Kano State. And we were presenting there 2 weeks ago in a scout camp. And so we were helping the scout to qualify for the STEM badge, for the satellite badge. I was a scout. I have my cooking badge, my swimming badge, but now we have a special badge called the satellite badge, which is world first. So then, Dangote University would be the first in Nigeria and the first in the whole of Africa and the rest of the world to be able to reach out to hundreds of millions of students throughout Africa for a start. Through all these little innovation centers that they can start, and then there's a lot of students making products, innovations, and that sort of money then will have the chance to compete with people like Elon Musk and send out maybe 6,000 or 10,000 satellites that have very little lag time or no lag time. So we need to show you the two different types of satellites that we are talking about.
Okay.
Yeah, the low-cost satellite, if you have many of them, they come over every few minutes rather than, in fact, less than 1 minute, then you have a continuous internet that doesn't break. And reliable internet in Africa. But to get to that level, you have to skill the people. And the Dangote University exercise shows us that they can do it. These students are very smart. You give them the opportunity, whether it's Lagos University, whether it's other university in Abuja, they're all the same. It's just they don't have the technology. And just to show you how this satellite connection can be made now is a technology we developed called RunLink AI. It's basically a ChatGPT type of technology that helps you to develop a report very quickly. But in our case, it's not a report. It's actually control.
Okay.
So these students will then be able to send information to satellite, the few satellites that is there, and then they'll be able to receive it. For the listening audience, it's not GPS. It's not the global positioning system where you just receive signals from the satellite. This is 12, 13-year-old students sending signals to the satellite and receiving it back. For instance, a young girl here, 13 years old, she make a bushfire early warning system for her beehives. Very far away from her house, about 5 hours. Right? But 100 beehives, she choose the area carefully so that it produces the best honey. But very far from her house, 5 hours. Now, if the bushfire comes, there's no internet there.
Okay.
All the 100 houses will be burnt.
Mr. Chu.
So now with the satellite connection, she's able to predict when with the temperature sensor,
Okay.
green grass is safe, 30 degrees, If it goes up to about 60 degrees, she has to get there quickly before the fire come already to move the hives. That is a classic application that nobody in the world has. And Africa has started now in Nigeria.
Okay, thank you for that analysis. Now let me go to Mr. KOSTECKI and let's talk about the technical challenge. You've told us, Mr. Chu, have told us about the benefit. We have been talking about the benefit, and there's nothing that will have so much benefit without having the challenges that will come out from it. So let's talk about the technical challenges you think maintaining the IoT satellite systems will come with, how those who want to use it for their businesses, be it large, medium, small scale, will have to deal with when it comes. So they should get prepared before they can launch into the satellite way of adjusting to running their businesses. So Mr. KOSTECKI, let's talk about the technical challenges involved and how you think those who want to use it can overcome it.
There is certainly technical challenges. I mean, I have a satellite transceiver here, for example, from the local company, Low Earth Orbit Satellite, and it comes with a development package. But the package is actually so difficult that even us, we're actually an electronic company, it took us a long time even to open and to get that up and running. So it's possibly, for someone that's in a small business, it's not possible. It just becomes too difficult. And even if they got some sort of help as well, then they suddenly obviously have to pay someone to develop some app or some application that they need. So this is just a development system, and this is quite typical for the low-cost systems. They might be low cost, but they might be too difficult to actually put in. So that's why we have actually come along and we've come up with a solution to that as well, so that using a low-cost, easy code development system, that they're actually able to put it in technically. And even recently, what we added technically to overcome this problem of it becoming too difficult to apply is we've got artificial intelligence now. You know, AI is used now for everything. The ChatGPTs are used for business and many applications. But suddenly, even the development of things like installing a satellite system for the application has become easy enough. Then suddenly they can just use simple sentences and suddenly construct that what they need, whether it's a farmer measuring the tank level or the river level, etc. They can use that. It's called RunLink AI, and this is probably the most advanced system so that they can reduce their costs by the time they'll be able to do that themselves.
Okay, let me still stay with Mr. KOSTECKI, and let's talk about how businesses can leverage. The leverage matters now since it is new in Africa and is something that you have started over there in Asia, and you want to transfer all the knowledge here to Africa. Let's talk about how you think businesses can leverage on everything that you've been talking about, the benefit. To businesses, what is the best way to come in and how can they come in?
Sorry, the question is directed to me?
Yeah, Mr. KOSTECKI.
Yeah, okay, sure. So one of the ways to really benefit and I think leverage on this technology is for those businesses that have access to the technology. I think the leverage part, I have seen a very good leverage in if the businesses actually adopt a student-industry partnership. You know, sometimes we have university students that can actually help the businesses to help to develop some of these things. The university benefits, okay, the students obviously benefit, but the business actually benefits in that case as well because they get that development cycle, they actually get the help that they need to be able to put this in. And so with this running system I was talking about, the students can actually even help the businesses, of course, as well. So there's a collaboration, student-industry partnership, and we've seen that working here very well. I have here an example for that recently a student was able to help develop a smart farm system using these high reliability piping from Novafast here in Australia, and a student industry partnership worked very well in that he was even able to present and promote this. He even won international competitions, and that obviously is helping obviously the industry there as well, and he ended up actually getting a job out of it himself as well. So this is really leveraging together.
Okay, Mr. Chu, let's talk about other sectors. We've been talking about tech and industries and schools. Let's delve into agriculture or energy. Which specific advantage do you think satellite IoT can provide for technologies which other technologies cannot? For instance, in agriculture, Mr. Chu, in agriculture, we should have something that will enhance productivity, enhance the way the produce are being taken out or harvesting. We should have ways of doing the processing. So can satellite IoT help us in agriculture or in the energy sector so that other technologies that we think cannot do it will rest, and this satellite development will do that? Mr. Chu.
Thank you again for the question. Start with agriculture. We are in collaboration with a number of universities in Africa on using satellite IoT to monitor all this important data for the farming, for the agriculture, right? For instance, you may have a drone that is able to take data in a farm that is very far away from very remote area that has, again, no internet and no Wi-Fi. And that is the use of satellite IoT in places that have no internet and no connectivity, no mobile connectivity. So this drone take all the data of colors changing of the maize, what sort of disease is affecting them, and these data are sent real time to the satellite, and then down onto the laptop, in the university. And so they can then process the data of this experimental farm for farming, and because it's at this very infancy stage at the moment in this sort of farming. In Australia, it's very advanced already. So they want to do the same thing what we do here in Australia. And so that is one area of application that is very useful for farming businesses. For the energy sector, as I said, businesses that are into refining petroleum, into transportation of energy, you need tracking of critical data, because you will lose a lot of money, hundreds of millions of dollars if there is an explosion, because you can't monitor. You don't monitor the leakage of your petroleum or the gas, and you pollute the environment. In the Western countries, that's extremely expensive environmental damage, right? And not only that, human life too, like the explosion in Malaysia. Luckily, nobody was killed, but many people were injured because of the explosion of this tracking of this energy pipeline, which is a nightmare. It's a time bomb ready to go off, because pipes last for about 20 years, the normal pipes. And that's why the ambassador of Nigeria, based in Canberra, came to visit this company that makes specialized pipes. They want these Novafast pipes to be made in Nigeria. And you can put that into acid, and it wouldn't affect it because it's made of composite, high reliability composite material made by robots. And so these are the sort of collaboration that we have with energy sector. And this company is a large company, and the ambassador and her staff, her first secretaries, and came to visit us about a month ago. And there they were shocked to see a little EV, 11 years old, I think he's standing by here somewhere, wanting to share his experience of how he can actually connect to satellite. So we're talking about profitability for businesses that can be helped by hundreds of thousands, if not millions of 11-year-old boys, girls, that are beginning to get into the knowledge of satellite IoT in order to help businesses to make profit, to increase customers. You know, if he can put a QR code onto the Dangote noodles, and he will be able to help to increase profits to Dangote noodle by helping the customers' children, the noodle customers' children, to win competition and scholarships. That's the relationship that is beyond normal imagination of people imagining that when we talk about satellite IoT, they only talk about directly the business. But they don't, they have no sense that it can be connected to hundreds of thousands, if not millions of students to attack the same problem of satellite IoT. Because I mentioned about Dangote University already, yes, students are capable of connecting to satellites to monitor all the pipelines' critical data. But they don't have opportunity, they never heard of such a technology that Miro was talking about. What they are learning may take 100 hours. What they're using AI, like ChatGPT, is reduced to a few minutes.
Minutes, okay.
100 hours reduced to a few minutes. I thought Abdul Jimo from Ocean University reduced 100 hours to 10 hours is a big deal. But now just the last few weeks, we reduce it to a few minutes because you need coding to be able to connect to satellite. And now kids as young as 11 years old from Nigeria, he is now living in Australia, and he showed the ambassador and her first secretaries how he's able to connect to satellite in Adelaide. It's only a month ago.
So all of these are possible if we put in the right infrastructure. Is that what you're saying?
It's the right leadership. It's the right amount of funding to the Dangote type of universities and schools, and it can happen right throughout Africa. It's just the lack of this technology, the AI technology, just like Gemini or ChatGPT is now used for control, for sensing, for data logging, which never has been done before. You know, even our technology is 100 hours reduced to 10 hours. We're still not happy. Now we reduce it to 10 minutes. And kids can do it. And that is talking about profit. And they can easily put QR code into cement, Dangote cement, BUS cement, or noodles. And these are kids connecting to industry already. That is money, that's profit. Because the more people innovate, the more profits the small businesses will make because they need the technology to connect to satellites.
Okay, talking about the business perspective of the satellite IoT, let Mr. KOSTECKI answer this question. Let's look at how companies can evaluate the return on investment. Mr. KOSTECKI, how can companies evaluate the returns on investment when using or when they want to consider an investment in satellite IoT infrastructure? Is it immediate? How long will it take before you can realize the amount that you have put in it, or it is something that you should invest in and just relax and say a year, 10 years, and 20 years before you can get your return on investment? Mr. KOSTECKI.
No, these technologies are changing so quickly that you can't wait for that long. Definitely you can't wait for that long. All the things are changing very fast. So the problem is that the first thing of investment is that you need to actually invest the time as to where you want to put them in. You need to put in the time to do the research. You then need to put in the time to actually put the system together. And even that, by the time you do that, because these systems have been so difficult, by the time you do that, something new has come out. So it has been very difficult in the past to be able to invest these sort of rapidly developing technologies. So that's why, for example, we've come up with this rapid development technology where if they invest a little bit into using the right technologies, then they'll save so much time. You know, I mean, instead of spending a year or two in development. And we recently we even spoke to a company, an industry, they actually, spend millions of dollars, but they went and they tried to put in the satellite system, and they ended up actually losing a lot of money because they couldn't do it. It was that difficult. So you need to make sure that you're using the right system, such as our running IoT system, to connect to the satellites. Don't spend so much time, make it work, then put it in as quickly as you can, and then use it to then increase your profits as well. So it needs to be rapid implementation for it to actually be a return. You need to be able to do that as well. And then also, if you do, like I said, connect to universities, student industry, then you can keep up with the rapidly evolving technologies, such as the AI. You know, the AI is coming out and evolving as well together in parallel.
Okay, so staying with Mr. KOSTECKI, let's talk about the data security measures that should be put in place, since we want to tilt the focus of people away from the traditional way of using the internet or the digital space. Let's look at the security measures that should be put in place. What do you think will be the security measures that whoever is any stakeholder that want to come into that sector should always check before they embark on the journey of creating the satellite-based development that we are talking about?
We're talking about low Earth orbit satellites with small packets of data. Those small packets, they're not connected to the internet system. So normally you have a controller. You know, you might have a controller, you know, such as this one. You're actually measuring then humidity, temperature, water level, etc. You make the measurement. You then connect to the transceiver, such as this one. You send it to the satellite just as a small packet. That's not connected with anyone else, so there's no security issue with that. Unless, of course, someone else has access to those things. So you have to think about that. When it gets to the satellite then goes to the satellite company that has security measures put in place. And usually the satellite company does not even store your data. They don't even want to take that risk. They ask you to simply give a link as to where you want your data sent immediately. Then, of course, you need to consider how you then collect that data and how you secure it yourself. And they are the normal measures that you would take collecting any data then as well, using the cyber security measures. So in some way, collecting the data is actually very secure. When you're receiving the data, you need to be very careful as well as to who then has access to the data. I think the access is usually what you need to limit and be very careful with, even the development cycle too.
So are you saying it is 100% free from fraud, internet fraud?
No, because when you collect the data, then you have to make sure that you yourself have to be careful about that internet fraud and put in the measures as well. If you put in the correct measures, then it can be. But if you don't put in those measures, then of course people can also have access to your data. So you need to be very careful how you do that.
Okay, thank you for that. Now, Mr. Chu, let's talk about the protocols that companies, or the global standard that you think companies must follow, operational standards, protocol standards, or the strategies that companies need to follow if they want to use the satellite-based ways of doing things, especially for businesses, industries, schools, as we have mentioned. Do we have a laid-down rule for companies to follow if they want to lodge into this kind of a development, Mr. Chu?
Absolutely.
Okay.
These are, you're talking about space, new frontier for most people, and so there are rules and regulations with the authorities. You have to follow the protocols. Like if we want to operate in Malaysia, we have to get the Malaysian Telecommunication Authority to approve this satellites that we are talking about in order to be used by these businesses in Malaysia. So there's definitely this aspect of protocol you have to follow. But Miro may be able to add a bit more to this technical aspect.
All right, the regulatory differences from countries to countries, do you think it's affecting the way people are perceiving or accepting the satellite-based IoT that we're talking about? For instance, in Nigeria or in Africa, do you see the difference of acceptability compared to the Asia or the continent? And how do you think the acceptability can go all across so that everybody can be on a global space at the same time using the real time to do whatever they want to do using the satellite AOT?
Okay, if I can answer that question, the definitely, you know, the regulations in each country do affect whether there's the businesses can access the things as well. So I think that you know, those regulations need to be able to be opened up so that they can keep up with the technology. Sometimes the authorities are delaying, you know, approving certain technologies. There's usually two regulatory bodies. One might be the frequency body because the signals are being sent, you know, and the other one is the space authority. So when something new comes in, they have to then approve those new technologies as well. So definitely those sort of things need to go through so that once they're approved, then it's actually becomes reasonably easy once the products themselves are approved for the companies, for the businesses to be able to use them already. So the ones that are, if they're not approved, it becomes a problem. If they become approved, then of course the businesses are able to access them. So let's hope for more rapid approvals from the authority for those regulations.
Okay. Mr. Chu, let's talk about the environmental or sustainability of this new innovation to businesses. Do you think it can be sustainable? And how well do you think people globally will accept it if we want to look at the sustainability and the benefit involved in it? How do you think people will accept looking at the environment, looking at the return on investment, looking at people involved, all the stakeholders who will push everything forward? How acceptable, or should we look at the environment and just sit and not go with the satellite-based development that we are talking about?
Thank you again. In terms of sustainability, it's all based on rule-based. There have to be rules when you talk about satellite in space. So the regulations become critical in order to sustain what you call a long-term sort of accessibility for people, for businesses, for anybody. So that's why we have a program for scouts to democratize space, student scouts. There are 8 million scouts in Africa, 57 million in total in the world. Between two Asian countries, Thailand and Indonesia, already 27 million scouts. 7 in Thailand, 20 million in, what do you call, Indonesia. 27 out of 57 million. 48% are in 2 countries. How? They make it compulsory. Now these scouts will democratize space and make it sustainable. So everybody have a say. If not, there's only a few rich men in the big countries that will dominate the space. So in order for you to sustain a program that relates to space for satellite IoT, you need to have a lot of people to participate. Miro just described, no students in the world, in school, connect to satellite. We have to be challenged to find out one 12-year-old kid, 11-year-old Ife in Adelaide from Nigeria, I think from the Ambra state or something like that. His father, Edward, is also listening in. They are in somewhere in the waiting room or something. And he used to work for UBA, Union Bank of Africa. And so his son was the one showing the ambassador how critical it is to have access to satellite IoT to make it sustainable for everybody. We have the technology that make it happen. Africa, Nigeria could be the first country to have that legacy. To have all students accessing space. Yeah, and you talk about return on investment, which other country can access it if it's only Nigeria? You are in the front foot already. The ambassador was here. She visited this pipe company, which failed to connect to satellite. We did it for them. So we have the ability, the capability to do that because of the AI technology that we have. So meaning that you have taken 100 hours, we will take less than 10 minutes to do apple-to-apple comparison of the coding of the procedure to connect to satellites. And kids as young as 11 years old, Ife, 13-year-old Vala from India, already done it. They win major competitions judged by top judges, professors. All students will be competing in world competitions on what they call STEM, science, technology, engineering, maths. I think you mentioned about Bimbo, who is also having a program on ICT. We would like to get these kids onto that program. And these Nigerian kids, as well as Indian kids, the Malaysian students and the professors in another program to share what I've just said. Because I think we are coming to an end of this session already. Right? So this is the excitement of the right question that you asked about sustainability of this satellite Internet of Things in that simple terms. We have the technology, you need to give them the access. Like for instance, I'll give it in reverse. Ambassador is working so hard to bring $10 million investment of pipes into Nigeria to increase the profitability of these businesses that need pipes like Dangote, or BUN. And yet, IFE has already demonstrated beyond any doubt using our technology, the AI technology, the Gemini, the ChatGPT for real life control, that he is able to do in a fraction of the time. Imagine there's 1 million teachers teaching coding in schools and STEM, making satellite connection. Let's even say it is possible using the other technology, which you have to check it out, and I don't think you will find one. Let's say they can do it in 100 hours. 1 million teachers pay 1,000 US dollars per year to teach that 100 hours. If he's sure, he can halve the time. Time is money. You don't have to take 100 hours. You only, the teachers, 1 million teachers only need 50 hours. That is 1 million teachers on 1,000 US dollars is $1 billion. And if he has already proven that he can save Nigeria 500 million US dollars. And the ambassador is working so hard to try to get $10 million, $1 million investment into Nigeria. That's called sustainability. If you have the ability to identify issues like this, problem like this, saving money is making money. Okay. So if he is already making $500 million US for Nigeria.
Okay, as we round up, Mr. Chu, are there ethical concerns that Nigerians, since you're using Nigeria and the ambassador as examples now, should we have any ethical concern about the satellite if we want to launch it and use it fully in all our operations, industries, schools, and all that? Should we start looking at the ethical concerns about this? Mr. Chu, can you hear me?
Well, as I said, yes, as I said, everything has rules, the ethics of rules. Okay. You give them good education, they will not do the wrong thing.
Okay. All right.
And you start educating them from primary school, because no primary schools in Nigeria or the whole of Africa or America, primary school, have access to satellite in their projects. And we have already this session in Dangote University. I hope Mr. Dangote is listening in. So his university become the world first to have 100 million students connecting to satellites in the whole of Africa.
So, Mr. KOSTECKI, what's your parting shot for us on the program about the satellite IoT? Should we stay with it, or do we look at the risk and then run away?
I think that we now have new technologies where it reduces the risk. That's the thing. So you can reduce the risk by making sure that you can quickly develop your satellite application. You can test it quickly, you can put it in, and that will certainly reduce the risk of the development time on there as well. And you can make sure that it is working correctly. And there is big return on investment. If you can actually do that, then you can save, for example, you know, some businesses, such as just someone looking after a beehive, they have to travel maybe 100 or 200 kilometers to go and check on their beehives if it's out on the orchard, and then they have to travel back, and they might need to do this once a week or something. So you know, how much time and money can you save if you just have a satellite monitoring your things, and you don't have to go there very often, but you can check it much more regularly. You can actually see what is happening every day. So this is just one example. Businesses like that can really benefit into putting it in.
All right, I want to thank you so much, Mr. MIROSLAV KOSTECKI, who is the Chief Technology Officer of STEMSEL Foundation there in Australia, for coming on the program. Thank you for sharing your thoughts with us. Thank you so much. And Mr. Ben Chu, who is the Chief Executive Officer of STEMSEL Foundation in Australia. Thank you for your thoughts, and thank you for educating us on the satellite IoT, as you have said.
Thank you. Thank you for this opportunity to share this wonderful experience, especially with the participation of Nigerian diaspora as well as Nigerians. Like Victor from the university in Nigeria is listening in too. I think he would have the chance if we have the next session with Bimbo on the ICT program.
All right, thank you so much. We are glad to tell you that that will be the end of the program, and next week promises to be another interesting one on the Profit Point Show, when we come again to talk about how you can grow your business and ensure that you are a partaker in the economic growth of Nigeria and the global space. My name is Charity James, but before I leave you to go, don't forget that you can join us on the program on any of our segments. That is the business review segment and the sectorial segment. You can sponsor or place your advert by calling this number 0803-396-0423, 0803-396-0423. That is the number to call to join us on Ogtv and place your advert or sponsor every of our program. Thank you for watching today's program with us. Until next time, have a good week ahead of you.